Okay, so we did a little bit of work with exponential functions. Now we're going to do a little work with logarithmic functions. And so the definition of a logarithmic function with base b. This is how it's defined. Y equals log base b. That is a subscript. Okay, it's lower than the actual logarithmic word. X, if and only if b to the y equals x. X has to be greater than 0, which means it has to be positive. B has to be greater than 0, which means B has to be positive, and B cannot equal 1. Okay? Up until this point, you had dealt with logarithms with base 10, because that's our number system. 10 refers to the number of digits we have, 0 through 9. Okay? We can look at other bases like 2, 3, 4, etc. And so that's what this refers to. And I'll be honest with you, when I was in your shoes, I didn't fully understand these. And then I found a little trick when I was in college that worked really, really well. Okay? I'm going to look at this original equation, y equals log base b of x. I'm going to find the base. The base here is b, right? So to both sides, I'm going to put that b. And what do I notice on the left? I have b to the y. Oh, where does that correlate? Okay, here, b log base b, those are inverses, they cancel out. So what does that leave me with on the right? X, because the logarithm, base b and b cancel. Okay, and so we're going to do that today, and it's actually not that bad at all. Now the question is, where are logarithms actually used? Believe it or not, these are just 5 links where they're actually used. In Haiti, I don't know if you remember, there was an earthquake back a while ago, okay, and the earthquake was defined with the Richter scale using a logarithm, the intensity of the earthquake. Okay, so in 1935 it says Charles Richter defined the magnitude of an earthquake to be m equals logarithm of I over s, where I is the intensity and s is the intensity of a standard earthquake. Okay, so that's an example of where logarithms are used. They're used a lot in science, money, music, sound, climatology. Okay, example in science, they're dealing with pHs here. Okay, they're talking about acidic and alkaline solutions. Okay, so if you notice, pH is the negative logarithm of the hydrogen ion concentration. Notice where a logarithm's used there. Okay, so logarithms are actually used a lot. Okay, without people actually knowing. So let's go ahead and look at some basic properties of logarithms. I don't know if you need to write these down so much as if you're just familiar with them. There is a chart in your book. Okay, basically, the log base b of 1 is 0, and that's kind of one of those important ones, so you might want to jot this one down. The log of any base of the number 1 is 0. Okay. The log of any base of the number 1 is 0. Okay, now if I look at the next one here, what's the power of b? 1, right? One of the things I told you is that the logarithms and the exponents are inverse operations, they cancel each other out. So one of the things about this is log base b and b can cancel each other out, and that's why that equals 1. So on the next one, log base b and b with an exponent, they can cancel each other out. That leaves me with x. Okay. On the bottom, b, log base b, they can cancel each other out. That leaves you with x. So that's the thing that you need to understand. Exponents and logarithms, they cancel each other out. Okay, they're inverse operations. So with that in mind, we're going to move into an example. It says evaluate each logarithm. Okay, evaluate each logarithm. So now, if I go back to the previous slide, the b and the little b and the number b were the same, right? So I could cancel them out. So I need to figure out if there is a way that I can write 81 as a power of 3. So is there a way that I can write 81 as a power of 3? 3 to the what? 3 to the what? 4. Okay, so then really, what we just looked at the previous slide with the properties, the log base 3 and the 3 cancel each other out, and that leaves me with 4. Okay, see how that works? You want your base, and then that base of the exponent to be the same number so you can cancel them out. So now, once again, I need to write this as 5 to some power so I can cancel it out and get my answer. What do I know that the square root is in terms of a power? What's the exponent going to be? What? It's not. How can I write that square root as an exponent?
Squared.
Not squared. Not to the negative.
Positive.
No. You can't remember.
Tell us, please.
What does that equal? If you square this some x, right? Okay, so let's think about it in terms of numbers. Okay, this is x to the first power here, right? So I have x squared. I have to put a number here so that when I multiply it, I get the number 1. So what times 2 will give me the number 1? 1/2. 2 times 1/2 is 1. So really, this is log base 5 of 5 to the 1/2. Okay? So then now, what's your answer going to be, guys? 1/2, because the log base 5 and 5 cancel each other out.
What happens if you can't get the exponent?
And you're not going to be able to do that part of today. Today you will be able to do all those problems with the same base. Okay? We will eventually cover that, and that uses the change of base formula, but that's later on. Nope. So this one's a little different because it's a fraction. So I need to think about fractions and what they mean. First of all, I'm going to look at the 49 because 49 I know is what? It's what? 7 squared. Good. So now I got to somehow get rid of that 1. So is there a way that I can write that fraction so that I don't have the number 1? Can't just do the reciprocal.
You just do it.
Notice where it's located. It's located in the what? Denominator. I want to move it up. So do we remember how we can do that with exponents? Make it what?
Negative.
Negative. Good. Okay. So what's your answer going to be here? Your answer will be -2. Okay. All right, this next one should be really easy. What's the answer going to be here? 1. Very good, because it's 2 to the first. Okay, so your answer here is going to be 1. All right.
Wouldn't it just be 3.2?
3.2. Good, because they just cancel. Ooh, next one.
I don't like those.
I know that it's really 2 to the 1/2, right? So I got to figure out what's the relationship between 2 and 16. What? What's the relationship between 2 and 16?
Two is
Now we're thinking about powers.
2
2
to the 4th.
to the 4th equals 16. Okay. So really, I have to write that as 16 to some power. How can I write 2 as a power of 16? So, how can I write 2 as a power of 16? Not negative. You're close. It's the what? Think it's 1/4. Very good. It's actually 16 to the 1/4 power. Okay? Because it's actually the reciprocal, or not reciprocal, it's actually the fractional value. And if you want to try that on your calculator, you could type in 16 to the 1/4 power, and that'll work. Now, before we cancel those out, I need to go ahead and multiply these two, because it's a power to a power. What is 1/4 times 1/2? 1/8. And so what is your answer going to be? 1/8. Okay? All right, for sake of time, we're going to be done for that part. We will continue with this tomorrow. And so if you want to go ahead and get started on your homework, it's going to be on page 178, 1 through 24. Okay? Now, real quick,